Alright, so let's jump in and do a reductio here on the Power of Logic website. I want to try out number 3. But let's just recall the idea behind a reductio is that we're going to make an assumption. We're going to assume the conclusion is false. So in a lot of ways it's like a conditional proof, but what we're going to do is at the end of the day show that if we make this assumption that it leads to a contradiction. So if we make some assumption here, we're operating under the assumption we can show that if this assumption were true, that would lead to a contradiction. Contradictions are always false, so the assumption must be false. And if that's the case, then we could ultimately say our conclusion is true by rule of reductio ad absurdum. That probably was confusing, but I think it'll make sense as we go here. And of course, if you ever need to stop, rewind, slow it down, think about something that was just said, do that to try to make these videos as useful as possible. Okay, let's just assume that G is false. We're operating here under the assumption that G is false. So on the basis of this assumption, what can we say? Well, if G is false, then we know that F must be true. Because the rule of disjunctive syllogism tells us that if one side of its disjunction is false, then we know that the other side must be true, assuming the disjunction was true at the beginning. I didn't number my premises up here. Okay, line 4. So we can say that F must be true, and that follows from lines 2 and lines 3, disjunctive syllogism. Okay, now if F is true, what do we know? Well, from line 1, we've got a conditional statement. We've satisfied the antecedent there with F. So we can say in line 5 that G would be true. And that follows from line 1 and line 4, modus ponens. Well, now look what we've got. We've got here in one line not G and another line G. Whenever you've got two things on separate lines, you can join them together by rule of conjunction. So I'm just going to say G and not G. Well, I didn't need all those spaces. From lines 3 and 5, conjunction. Now what we can do is move quickly, though the idea is this. If not G is true, then this contradiction would follow. So the assumption of not G must be false. That would be how we'd close this out if we were doing a conditional proof. And that should sort of make sense now that we can say that G would have to be true. So anyways, we're just going to say that. We're closing off the box, line 7. Therefore G, which was proven from lines 3 through 6 by rule of reductio ad absurdum. Let's check this out. Excellent! Congratulations, we've gotten it right. Now, some of you probably saw another method. We could have taken the not G and done a modus tollens on this conditional and generated our contradiction with the letter F here, rather than the letter G. Either way works. You assume your conclusion is false, show that a contradiction would follow, and then you ultimately get the opposite of your initial assumption. You know, you don't even have to use these solely on the conclusion. Anytime within a proof, if you were doing a larger proof, and you just needed to prove that something was true, maybe you needed to get it to say P or Q, just assume P or Q is false. If you could show that a contradiction would follow, then when you close off your box, you could say P or Q must be true, and then use that for whatever else you needed it for inside the proof. I hope this has been helpful. Of course, post any questions that you have. Even for specific problems, I can come on and do some more, and we will see you online.